So imagine looking on the horizon and sunrise is half the sky K. That would be terrifying. Will it explode or not? Astronomers and stargazers have long been fascinated by Betelgeuse, a dazzling red supergiant star in the constellation of Orion. The red supergiant star is the closest to Earth, probably less than 1,000 light-years away, or in cosmic terms, a hop and a skip. Neil deGrasse Tyson and other researchers have investigated the terrifying possibilities of what the James Webb Space Telescope, JWST, which possesses increased capabilities and extraordinary sensitivity, may reveal about Betelgeuse. Astronomers have been baffled by its recent episodes of dimming and unexpected behavior, which have raised concerns about this celestial giant's future and the potential for an impending supernova explosion. What does Neil Tyson have to say about this strange, volatile star acting the way it is? Is Betelgeuse about to blow up? Let's find out. Betelgeuse is a star that has long attracted the admiration and attention of humanity. It is one of the brightest stars in the night sky and one of the biggest stars ever found. But this luminous star monster is more complex than it first appears. The red supergiant star has an eye-catching orange-red color. This group of stars is nearing the conclusion of its lifespan. They blow up and stretch out into space as they get older, making them the biggest stars in the cosmos. 640 light-years separate us from Betelgeuse. If you see Betelgeuse in the night sky, you are seeing the star from 640 years ago because it takes the light from this star 640 years to reach Earth. Betelgeuse is not only easily identifiable by its distinctive color but also by its brightness. It frequently ranks as the 10th brightest star in the sky and is one of the biggest stars that can be seen with the unassisted eye. It is roughly 15 times more massive and nearly 700 times the size of the Sun. In fact, Betelgeuse is so enormous that it would extend past Jupiter's orbit if we replaced our Sun with it. Betelgeuse is around 10 million years younger than our Sun, which is almost 5 billion years old. Although it is considerably younger than our Sun, it is also much more massive, which means it will burn through its fuel more quickly and have a shorter lifespan. Betelgeuse, despite its size and brightness, has a surface temperature of about 6,000 degrees Fahrenheit, which is lower than the surface temperature of our Sun, about 10,000 degrees Fahrenheit. Betelgeuse has been the subject of extensive research throughout history due to its brightness, proximity to Earth, and ability to reveal characteristics that are not visible on fainter, more distant stars. Betelgeuse was probably known to even the earliest humans, according to scientists. Additionally, it appears in numerous cultures' mythologies and legends. The ancient Egyptians included Betelgeuse in the constellation Osiris, named after their mythological deity of the underworld. Even though many people refer to the star as being part of Orion named after the hunter from Greek mythology, the ancient Greek astronomer Claudius Ptolemy described it using the Greek word meaning a tint that can vary from pale yellow to light reddish. This may indicate that the star had not yet changed to its more recognizable reddish hue. In 1603, German astronomer Johann Bayer gave the star the Latin name with the prefix denoting that it is the brightest star in the constellation. Even though Rigel is now acknowledged to be the brightest star in Orion, Betelgeuse still goes by that name. Betelgeuse's brightness changed over time in 1836, but astronomer and mathematician Sir John Herschel was probably not the first to notice it. There is proof that Aboriginal oral traditions detailed the variability of Betelgeuse and other red giants far earlier. Since then, Betelgeuse has been categorized as a semi-regular variable star, a type that occasionally experiences erratic light shifts and periodically waxes and wanes in brightness. Betelgeuse normally has two cycles, one that lasts 400 days and another that lasts around 5 years. But a funny event happened in 2019. We'll come back to that. Because of internal thermonuclear fusion events, stars are bright. Simply put, they combine basic elements like hydrogen to produce more complex ones like helium, producing energy in the process. The simplest fuels run out in huge stars, 8 or more solar masses, as they age, but they gradually burn more complex fuels until their cores are eventually formed of iron, and the nuclear reaction stops. At that moment, the high temperatures in the star's interior begin to decrease because no more fusion is occurring, and as a result, the star's high internal pressures also decrease. The star starts to collapse inward, compressing before rebounding in a spectacular explosion known as a supernova. Therefore, After they run out of fuel, big stars like Betelgeuse burst as Type II supernovae, swiftly contracting and exploding violently. Much fuel it has remaining and how close it is to collapsing influences when it bursts. But what is happening within Betelgeuse? Neil deGrasse Tyson and other scientists concur that Betelgeuse's core carbon burning is nearing its end. For a big star like Betelgeuse, the carbon burning phase lasts for about 1,000 years. If that stage is near the end, Betelgeuse has likely reached the end of its lifespan and may be poised to erupt. But are there other possibilities? Naturally. Since surface conditions barely alter in a late stage close to carbon exhaustion and beyond, it is actually impossible to pinpoint the exact evolutionary stage. Astronomers can only observe the star's surface. Nevertheless, what happens inside the star provides a much more interesting story. Betelgeuse may erupt sooner than anticipated based on observations, data, and modeling. However, and this is crucial, they are unsure of the star's current state of core carbon burning. Some models suggest that carbon burning may continue for a very long time. When Betelgeuse started dramatically dimming in late 2019, it excited people worldwide. This event is now known as the Great Dimming of Betelgeuse. Many thought the star's explosion was imminent. Some researchers questioned whether Betelgeuse was approaching a pre-supernova phase, which precedes a giant star's catastrophic death in a supernova. The dramatic dimming was so significant that the world was intrigued by reports of the potential explosion. If Betelgeuse were to explode, it would be the nearest supernova ever seen and recorded by humanity. By April 2020, Betelgeuse's brightness had been restored to normal, but the cause of the dimming remained unknown. The bizarre event was initially difficult to explain, but the full picture didn't emerge until the following year. Researchers examining data from observatories like NASA's Hubble Space Telescope discovered that Betelgeuse blew its top in 2019. An enormous chunk of the star's surface material was ejected into space, cooling and condensing into a cloud of dust that momentarily obscured the star's light. For stars, material ejection is fairly typical. Our Sun frequently ejects material from its corona in processes known as coronal mass ejections, CMEs. But unlike the Sun's typical ejections, the Betelgeuse eruption was unusual. Betelgeuse ejected a rock into space that most likely weighed more than our Moon 400 billion times as much mass as is typically released during a CME. The large, previously unseen ejection may have resulted from a plume of gas rising from within the star, boosted by its typical 400-day pulsation cycle. But the precise reason and method behind it are still unknown. Scientists have been studying Betelgeuse and its peculiar behavior as the dust literally and figuratively settles. Although humanity has never seen anything like this surface mass ejection, it's possible that phenomena like this happen frequently throughout the cosmos. Betelgeuse's proximity, size, and our capacity to view it in fine detail with the Hubble Space Telescope allowed us to witness it at all. Betelgeuse is visible from many backyards, so there are plenty of observations. But scientists rely on observatories like Hubble and the Webb telescope to gain a detailed look at the star, its atmosphere, and how it is changing. Despite subsequent brightening and dimming, Betelgeuse hasn't yet exploded. The star's expulsion of a cloud of hot gas is now thought to have contributed to the Great Dimming. There is definitely a plot twist at Betelgeuse.